Hi, Alyssa. Thanks for sending your question. When we're evaluating inverse trig functions, it's very helpful to remember that there's a picture that goes with each of them. This picture is actually a picture of the domain of each of the trigonometric functions listed here. So over here I have the domain for arc sine. It goes from negative pi over 2 to pi over 2. Notice that this is not 3 pi over 2. And also notice that there's one place here where sine is negative and sine is positive. Going over to the second picture here, we have the domain for arc cosine. It goes from 0 to pi, and again, there's a place where cosine is negative and a place where cosine is positive. Those are both listed there. And same thing is going on with arctangent over here. The difference you'll see here is I have these big circles right here. What that means is that the domain of arctangent goes from negative pi over 2 to pi over 2, but that we don't actually include those endpoint values. So it's only everything in between. So I'm going to do the first three problems with you. Problems number 8 and 10, once you get the hang of it, you can start using the unit circle, and you should be able to figure those out on your own. So let's go ahead and evaluate the arc sine of 0. I'm going to go ahead and call this y. Why not? So I'm going to go ahead and rewrite this in English, which is what I used to do when I was learning this. So the arc sine of 0 is the angle, which we've called y here, whose sine is 0. Or another way of putting that is sine of this angle, sine of y, is equal to 0. So what we're going to do is we're going to go up to our picture for arc sine, and we're going to look at the place that's highlighted here in red, whose sine is 0. The only place whose sine is 0 highlighted in this picture is actually the angle 0. So the arc sine of 0 is actually 0, or 0 degrees. It's an angle. Let's go ahead and try number 4. The arc cosine of 0, let's again call that y, is the angle whose cosine is 0. Or if you need to rewrite it, you can rewrite cosine y is equal to 0. We're going to go up to our picture for arc cosine and look for the place highlighted in this picture where the cosine would be 0. The cosine is another name for the x-coordinate, and the sine is another name for the y-coordinate. So if you get confused, you can look for a place where the x-coordinate is equal to 0. That's always on the y-axis. So the place where the x-coordinate is equal to 0, or cosine is equal to 0, is right up here at pi over 2. So that's actually going to be our angle. That is the answer for this problem. Pi over 2 is also 90 degrees if you want to write it in that notation. Now for number 6, we're actually looking at arctangent. Let's go ahead and call this y again and rewrite it. So we're looking for the angle y whose tangent is -1. This one I'm going to go ahead and rewrite so that we remember that tangent is actually a ratio. So this is the same thing as saying sine y over cosine y is equal to -1, because tangent is a ratio of sine to cosine. And that's the same as saying that sine and cosine are really the same number, they're just opposite signs, and that's SIGN, meaning one's negative and one's positive, but they're the same number. So we're going to go up to our picture for arctangent, and you can use the unit circle at this point if you like, but we're going to find the angle where sine and cosine are the same number, so that angle is going to be pi over 4, but they're actually going to be opposite signs. So let's look. We have two quadrants here, one where arctan is positive and one where arctan is negative. Here we have a negative number, so we're going to be using the negative quadrant. So the answer for here is going to be pi, or -pi over 4. Again, I got this utilizing the unit circle and looking for the place where sine and cosine were the same number but opposite signs. So you should be able to do 8 and 10 on your own now. If you're not, just go ahead and repost them. Thanks again for your questions, and I look forward to answering more of your questions using Snap Math in the future.